we're going to be doing a real-world calculus problem just to illustrate how we can use this type of formula in a real-life situation. Our problem is a rectangular plot of farmland will be bounded by a river on one side and the other three sides by a single-strand electric fence. The farmer only had enough money to buy 1,300 meters of wire. What is the largest area you can enclose and what are the dimensions? Here's an illustration of our problem, and remember he only had 1,300 meters of wire. So let's draw a little diagram. X, X, question mark. This is the river. So we just have three sides to find. So the area is represented by X times 1,300 minus 2x. Now we distribute this x into the parentheses and we get 1,300x minus 2x squared equals a. Now this is going to be our formula for our max area as well. So we'll have to find these, we have to find x so we can plug it in and figure out what the max area is. So how do we find x? Well, first we have to take the derivative of this. So the derivative of this would be 1,300 minus 4x. And we have to set this equal to 0 because that's how we find what x is. So if we subtract 1,300 from each side, we'll end up with negative 4x equals negative 1,300. And then we have to divide by negative 4 on each side. And we get x equals negative divided by a negative is a positive, so it'll be a positive number, and that number is going to be 325 meters, because we're working with meters. So this represents this x and this x. So both of these sides, this is our shortest side, will be 325 meters. So we can figure out the largest area just using this side. We don't even have to find this side yet. So let's do that. So we take this and plug it in. So a of our x, which is 325, equals 1,300 times 325 minus 2 times 325 squared. So our max area will equal 211,250 meters squared. So this is our max area for inside the rectangle. So our area right here. But it also asks us to find every single side. So we found both of these shortest sides. So how do we find the question mark side? Well, the perimeter can be given as 1,300 minus 2x. So that's going to equal, no, it's not going to equal. So we plug in this x, which is this value we found for x, and we should get the other dimension. So that becomes 1,300 minus 2 times 325. And you subtract or multiply these and subtract it from that, and it becomes 650 meters. So we have our max area at 211,250 meters squared, so that's what is on the inside. And on the outside, the dimensions of that rectangle is, the dimensions are 325 times 6, or by 650 by 325. And those are all in meters. So there you have your answer.